Hello everyone and welcome to another short video on solving a LeetCode problem with APL. Today we will be tackling problem 1221, and this must be a good omen because 1221 is clearly a palindrome, so yeah, this must be a good problem. And it is because I've already read the problem statement, and the problem statement says that a balanced string is a string that has an equal quantity of L and R characters. And they say, well, take a balanced string as input and try to split it in the maximum amount of balanced strings possible and return that number. So we don't need to return the split string or the smallest of strings, we just need to count how many I can create. And as an example here, they give us this balanced string, and they say that we can split that input in these 4 balanced strings, and therefore the number is 4 because this is the maximum number of balanced substrings we can find. And now notice that this is not a matter of finding within the whole string. So for example, this is also balanced. Remember that we want to split, so we split here and then we split here and then here and then here. Now this is, I don't know if you've seen, I think it's John Scholl's video on, no, is it? I don't know. It's a within the APL community, there's a well-known snippet of code. It's very, very short. I think Code Report has a video on this. If he does, there will be a link in the description. I can't remember for sure. But there's a very well-known piece of APL code that checks if a string is balanced in the sense of parentheses. So given something like this, I don't know, 7 times 5, there's a very simple piece of APL code that you can use to check if this string is balanced in terms of parentheses, and we are going to use some ideas from that piece of code to find out how many times we can actually split this. So let's see, let's take this first example. It doesn't really matter. So our string is this. Now what we want to do is figure out where the R's are and where the L's are. And so in order to do that, we do RL times equals the string. And now what we do is we subtract one from the other. And now this gives us a vector that has ones for one of the letters and minus ones for the other letter. And now we do a plus scan on this. And essentially, every time we find a 0, it means that the string is balanced. Why is that? Because the ones correspond to the R's. And so we see here there's an R. So we can think of this as a scale with two plates, so those where you put some weights in and it tilts to one side or to the other. It tilts to the heavier side, right? So think of it exactly like this. This means that the left side is outweighing the right side, and now the 0 here is because the L is counteracting the R, and these are in balance, and that's why there's a 0 here. Then we add 2 consecutive R's, so there's too much weight on the R side, but then we add a left and another left, and so it's balanced again, and etc. And so the zeros here, we just need to count them. So we count the number of zeros. And this is our solution, it's just this. And to show you another example where things go negative, for example here, instead of RL, RRLL, let me swap the order, so LLRR. And let me show you this piece right here. So here we see that it becomes unbalanced because there's too many L's, but then it becomes balanced again because the R's counteract that. And yeah, that's it. I think this is a really nifty solution. I wonder if anyone can come up with something nicer than this. I'm not saying that I'm an APL master. I'm just saying that for this particular problem, I actually knew just a really good approach. So yeah, feel free to comment your alternative solutions down below in the comments, and if you do, just include a short description so that to try and prevent YouTube from deleting your comment because the APL glyphs look weird. Yeah, well, I'll see you in the next video, I guess, right? Bye.